Okay, so talking about simplifying radicals, one of the first things we covered in this unit, I'm going to talk about two different ways that we can solve one of these when we are trying to simplify. I have these numbers over here on the left side of the screen. They are perfect squares, just to remind us of some perfect squares that we can look for within the radical. So the first way we're going to want to do this is by dividing 3024 by one of these perfect squares, just kind of a guess and check just to see what will work. And I haven't worked this problem out yet, so I'm doing it with you on my calculator, and I'm going to choose to divide by 9. So I just divided by 9, and I got 9 times 336, okay? And remember, this is still under a radical because we're just creating equivalent statements. So 9 times 36 is the same thing as 3024, okay? So we haven't broken equality, all right? We're not doing any sort of witchcraft. We're just creating equivalent statements. So at this point, my thinking is that I know the square root of 9. All right, we know that that's 3, so I'm not going to have to mess with that anymore. I don't know the square root of 336. So in my calculator, I'm just going to take a guess, and I divided by 16, and it worked. 16 times 21. All right, and that 9 is still over there. So I now ask myself, do I know the square root of 9? Uh-huh. Do I know the square root of 16? Yes. Do I know the square root of 21? The answer to that should be no. So I got 7 times 3. And of course, I've still got 9 and 16. Okay, so now is when we can start to really break this thing down. Because 7 cannot be broken down anymore, 3 can't be broken down anymore, and I know the square root of 9 and 16. So I know the square root of 9 is 3. I know the square root of 16 is 4. And I'm just doing the pairs here just so you guys have a visual. I don't want to skip any steps for those of you that like circling pairs. But we know that the square root of 9 is 3. The square root of 16 is 4. And we don't know the square root of 7 or 3. So we're left with 3 times 4 times the square root of 7 times 3, leaving our answer to be 12 times the square root of 21. All right. So that's one way of doing it. All right, kind of the guess and check method that not all of you may be comfortable with. All right, so I'm going to clear the screen right now and start over on a different method. All right, so say we didn't want to test out all of our perfect squares. Say you just want to work with 2, because this is an even number. It ends in 4, so I know it can be divisible by 2. So on my calculator, I'm going to divide by 2, and I got 2 times 15, 12, so 1,512. All right, then I'm going to take 1,512, divide it by 2. So now I'm at 2 and 756. All right, now I'm going to divide 756 by 2, and I got 378. And now if I divide 378 by 2, I'm going to get 189. All right, so we've gotten ourselves to 189, which that is not an even number, so we're going to have trouble dividing it by 2 because it's not divisible by 2. So let's just try a guess. All right, since it ends in a 9, I just tried a 9 and it ended up working out. I divided by 9. I got 9 times 21. All right, we know that 9 can break into 3 and 3 because the square root of 9 is 3. We know that 21 from previously is 7 times 3. Okay, so this looks like a big jumbled mess, but let's back up a little bit and look at it full circle. All right, so we've got Now let's look at our full circle looking for our pairs of 2s. So I got a pair of 2s there. I got a pair of 2s there. I got a pair of 3s there. And I'm left with 7 times 3, right, without a pair. So if they are without a pair, I'm going to go ahead and leave those under the radical. 7 times 3. Since I had a pair of 2s, that's going to come out here. I got another pair of 2s, that's going to come out here. And I got a pair of 3s, so that is going to come out here. Alright, so now I've got numbers that are being multiplied together but completely broken down. So now let's multiply them. 2 times 2 times 3 will be 12, times the square root of 7 times 3, which is 21, and that is the same answer that we got before, just in a different way. It doesn't matter which way you do it, whichever one you feel more comfortable with. They both work, and they're both effective.